If Power Query says DataFormat.Error, or we couldn't convert to number or date, the real problem is almost never the whole column. It's usually one or two specific rows hiding inside thousands. The fastest path is not guessing formats. It's isolating the exact value that breaks the conversion, then deciding what to do with it. In this walkthrough, you'll use a repeatable method that works for numbers, dates, and even mixed text. You'll learn why the error often appears after a type change step, even if the data looked fine earlier. You'll also learn how to pinpoint the failing row without scrolling forever. And once you find it, you'll know the common culprits: invisible spaces, wrong separators, unexpected words, and locale issues. The goal is simple: find the exact row fast, fix it deliberately, and make your query resilient so the error doesn't come back next refresh. Next step. First, it helps to understand what Power Query is actually doing. When you set a column type to number or date, Power Query tries to parse every value into that type. If one value can't be interpreted, you get the conversion error. Sometimes the preview looks fine because you're only seeing the top rows. The bad value might be far down. Another twist is that Power Query may treat empty strings, dashes, or NA as text, not null. Those look harmless, but they break numeric conversion. Dates fail for similar reasons. A value can be a real date in one system, but arrive as text in another. Or it can be a different date order, like day-month versus month-day. The key takeaway is that the error is deterministic. There is a specific value that fails a specific conversion rule. Your job is to reveal that value and then decide whether to correct it, replace it, or keep it as null. Next step. The first practical move is to locate the step where things break. In most queries, the error appears right after a change type step. That step might be auto-generated, or it might be something you added. Don't delete it yet. Instead, duplicate the query or add a branch so you can experiment safely. Then click the step just before the error. At that point, the data is still intact. Now you can test conversions in a controlled way. This is important because later steps might filter rows, merge tables, or transform text, which can hide the original cause. By anchoring your debugging right before the failing step, you reduce the search space. You also avoid fixing the symptom instead of the cause. Think of it like debugging code. You don't start at the crash message. You start at the last known good state, then change one thing at a time until the failure reproduces. Next step. Now use the simplest built-in tool, keep errors. After the last good step, apply the conversion again, but in a way that lets you isolate failures. Convert the target column to number or date, then use the option to keep only rows with errors. This instantly shrinks your dataset to just the problematic records. If you get 0 rows, the error is coming from a different column or a later transformation. If you get a handful of rows, you've already won. You can now read the exact original value that failed. The trick is to keep a copy of the original column before converting. Duplicate the column, convert the duplicate, and then keep errors on the duplicate. That way you still have the raw text side by side with the failing conversion. This avoids the common frustration where the error row exists, but you can't easily see what it used to be. Next step. If you need speed on huge tables, use a binary search approach with row ranges. Add an index column starting at 0 or 1. Then try filtering to a range, like the first 50,000 rows, and apply the conversion. If it succeeds, the bad value is later. If it fails, it's inside that range. Halve the range again and repeat. This is the same logic used in debugging large log files. In a few iterations, you narrow from millions of rows down to a few dozen. The nice part is, you don't need any fancy functions. You're just using an index and a filter. Once the failing range is small, switch back to the keep errors method to list the exact rows. This approach is especially useful when the conversion error prevents the query from loading at all. You can still isolate the failure by working in smaller slices. Next step. A very common cause is invisible characters. A number like 123 converts fine, but 123 with a trailing space can fail in some situations. Non-breaking spaces are even worse because they look like normal spaces. Currency symbols, tab characters, and line breaks also sneak in from exports. The fastest fix is to clean the text before conversion. Use trimming to remove leading and trailing white space. Use cleaning to remove non-printable characters. If you suspect non-breaking spaces, replace that specific character with a normal space, then trim again. For dates, extra spaces around the value can also break parsing. The important mindset is this: conversion is not cleaning. Conversion assumes the text is already in a valid shape. So add a short sanitize step before you set the type. This one change prevents a lot of refresh failures later. Next step. The next big category is separators and locale. A value like 1234.56 might mean 1234, or it might mean 1.234, depending on the system. Same with dates like 03/4/2025. Is that March 4th or April 3rd? Power Query uses a locale when interpreting text as numbers or dates. If the file was produced in a different locale than your environment, conversions can fail, or worse, silently misinterpret values. The safer approach is explicit parsing. For numbers, use a conversion that specifies locale. For dates, parse using a known format or split the components. If you can't guarantee the incoming format, don't rely on automatic date detection. Normalize first, then convert. This is one of those trade-offs. Explicit steps take a bit longer to build, but they save you from subtle data corruption. Next step. Sometimes the bad value is not even a number or a date attempt. It's a placeholder. You'll see things like -NA, null, TBD, or unknown. Those are human-friendly, but they're not machine-friendly. Decide what they should mean. If they represent missing data, convert them to null before you change type. If they represent a special category, keep them in a separate text column and create a numeric column that is null when the placeholder appears. A clean pattern is create a conditional column that checks for known placeholders, outputs null, otherwise outputs the original value. Then convert that result to number or date. This makes your intent explicit. It also makes the query easier to maintain, because anyone reading it can see which placeholders were expected and how they're handled. Next step. Another sneaky cause is mixed data types created earlier in the query. For example, you might merge tables, expand columns, or append files from a folder. One file has a proper date, another has a text label in the same column. Or one source uses integers, another uses decimals with a different separator. When you append, Power Query tries to align columns by name, not by meaning. So you can end up with a column that is mostly numeric, but occasionally contains text. The fix is to standardize at the source boundary. If you're combining files, apply the same cleanup function to each file before appending. If you're merging, ensure both sides use the same type and format before the join. This is also where profiling helps. Look at distinct values, unexpected categories, and error counts. The goal is consistency before typing, not after. Next step. When you found the exact row, you still need a robust way to convert without breaking refresh. One pattern is try otherwise. Instead of directly converting, you attempt the conversion and return null when it fails. That keeps the query loading, and it isolates bad values for review. A practical setup is 2 columns, a parsed number column using try conversion, and a parse error flag column that marks which rows failed. You can then filter or report on those failures without stopping the whole pipeline. The trade-off is that you might hide a serious upstream issue, so use this pattern when you expect occasional dirty data and you want the model to keep running. If the data must be perfect, you can still use try otherwise during debugging, then switch back to strict conversion once the upstream source is fixed. Next step. Dates deserve their own quick checklist because they fail in unique ways. First, watch for timestamps mixed with dates, like 2025-01-05-14-32-10. That might require converting to date time first, then extracting the date. Second, watch for invalid dates, like 2025-02-30. Those often come from manual entry or system bugs. Third, watch for text months, like 5 Jan 2025, which may parse differently depending on language settings. A reliable strategy is to normalize dates into a standard text format, like year, month, day, using splitting or extraction. Then convert that normalized text to a date. If you're dealing with multiple formats, detect patterns first. For example, if a value contains a dash, parse one way. If it contains a slash, parse another way. It's not glamorous, but it's predictable, and predictable beats mysterious refresh errors. Next step. Numbers also have recurring traps. Percent signs, currency symbols, and parentheses for negatives are the big three. $1200 is not a number until you remove the dollar sign and normalize separators. 45% might need to become 0.45 or 45, depending on your business meaning. And 123 is often used to mean negative 123 in accounting exports. Another trap is scientific notation or long IDs. A value like 001234 might be an identifier, not a number to calculate with. If you convert it to number, you lose leading zeros. So before converting, ask one question. Is this truly numeric data, or is it text that looks numeric? If it's an ID, keep it as text. If it's a measure, clean symbols, and then convert with an explicit locale. Next step. Once you've fixed the immediate issue, lock in a workflow that prevents the next one. Keep your change type step close to the end, after cleanup, but before heavy modeling steps. Add lightweight validation checks, like counting error rows after parsing. If the count is above 0, you can route those rows to a separate table for review. Document the expected formats in the query itself using clear step names. And if your data comes from a folder of files, treat the sample file as untrusted. New files will eventually differ. Build your transformation function to handle common variations, extra spaces, placeholders, and locale differences. This is the difference between a query that works once and a query that survives. The goal isn't perfection. It's controlled behavior when the source data is imperfect. Next step. Here's a quick mental flow you can reuse every time. 1. Identify the step that introduces the error. 2. Duplicate the column and convert the duplicate. 3. Keep only errors to reveal the exact raw values. 4. Classify the cause: whitespace, placeholder text, separators, locale, mixed sources, or true invalid data. 5. Choose a fix that matches your intent. Replace, parse explicitly, or use try conversion with a flag. If you follow that sequence, you stop spending time on random experiments. You'll also get faster at spotting patterns. The same few issues show up again and again, just in different clothing. If you want, you can turn this into a reusable template query, especially for folder imports. Before wrapping up, I'm curious which error you hit more often in real work: number conversions or date conversions. Leave a comment with A for number or B for date. And if you want more Power Query debugging workflows like this, subscribe. Subscribe to keep optimizing your workflow and get back more of your time.